No solutions. It's entirely positive. It will never be negative. It will never touch the x-axis. It's a very good problem. It makes us think for a moment. So we move everything to one side. We have to write the equation on the side because we have to solve it since we need the x-intercepts. But there are none. Then, because the leading coefficient is 1, we establish that the graph is way above the x-axis. There is no x that makes it 0. There is no x that makes it negative. It's all positive. But a positive number can never be less than or equal to 0. Therefore, this inequality has absolutely no solutions. There is no x that I could plug in here to get 0 or a negative number. Is the idea clear? Yes, maybe?
Yes.
Okay, perfect. Thank you for picking that. It was a good one. Good. Anything else from the polynomials or rationals? Anyone? So this was a polynomial. Do we need another polynomial? Do we need a rational?
Can we do a rational?
Yes, please. Choose any rational you want. Of course.
Can we do 53?
Yes, of course. 53. I see it. Very good. In 53, we have x plus 4, x minus 1 over x plus 2 less than or equal to 0. Okay, this is a straightforward situation in which we have to have the table with x as the variable in the problem, with x plus 4, with x minus 1, with x plus 2, and then the whole thing, all this. Then I have to find where this is 0, where this is 0, where this is 0, and be very careful to put them in ascending order, in the correct order from left to right. So where is this 0? When x is?
-4.
Good. So let's put them on the side. Where is this 0? When x is?
1.
Perfect. And where is this 0?
-2.
-2. So carefully, I put -4 first, -2 next, and 1 last. But now, under -4, this one is 0. Under -2, this one is 0. And under 1, this one is 0. And of course, it's a product, and the denominator can never be 0. So I know that there is nothing I can put under -2 because the denominator is 0, the fraction is undefined. But here I have a 0, and here I have a 0 because I know forever that the numerator, when the numerator is 0, the fraction is 0. But when the denominator is 0, there is a big problem. I don't have anything to write. If you remember, when we graphed these, this was a vertical asymptote because the function is not defined there. Now, I realize that all these three are very nice. They all look like this. They come from negative, cross the x-axis somewhere, and then go positive. So I don't have to think. I'm not saying that we shouldn't. I'm just saying it's very easy if you remember this little trick. So negative before crossing the x-axis, positive afterwards. Negative before crossing the x-axis at 1, positive, and the same thing, all of them, because make sure that they are presented in descending order so you don't miss the fact that the leading coefficient, which is the slope of a line here, is positive. And now, I only count negatives. The positives will not change anything. 3 negatives, 2 negatives, 1 negative, no negatives. So I'm asked to find negative because only negative is less than or equal to 0. So is there a negative? Yes, here. Is there another negative? Yes, here. But I have to be careful not to include negative 2. I will include negative 4 because the equal symbol is there. I will include 1 because the equal symbol is there. But I cannot include negative 2 because negative 2 presents or makes this undefined. It doesn't exist. So I'm ready to write the final solution. And as I mentioned before, I prefer writing x in so it's clear, although it's clear now because I'm going to have negative infinity, la la la. So, but in general, okay. So negative infinity to negative 4 closed, in other words, bracket when we say closed. Union, I cannot close negative 2, not allowed. Comma, 1 is allowed. Is this okay?
Yes.
I hope you are registered for the final exam. That would be a terrible, potentially terrible situation because I'm sure they are fully booked by now. Okay, good. Anything else? Other topics?
Can we do an inverse function?
Yes, of course. Good point. So let's say f of x equals negative 2x plus 7. I know that this is a linear function with a negative slope. By the horizontal line test is 1 to 1. And we want to find its inverse. If you remember, it's a 4-step procedure. In step number 1, we replace this by y. In step number 2, we swap the two variables. Where I see y, I put x. Where I see x, I put y. In step 3, I have to solve for y. So I'll move 7 to the other side. Negative 2y equals x minus 7. And carefully divide by negative 2 term by term. Y, negative 1/2 x plus 7 halves. 1 divided by negative 2, negative 7 divided by negative 2. And this is it. Final step, I replace this by the symbol F inverse. And this is it. Good.
Yes, thank you.
Thank you. Now, if I am asked to graph the function, any function, and its inverse, let's say, much simpler. Let's look at a simpler function. Let's say I have x plus 4. So, 2 points. When x is 0, y is 4. So 0, 4. When y is 0, x is negative 4. So negative 4, 0. So I have the inverse or I don't have the inverse, it doesn't matter. Because I'm sure you remember something very interesting and important. So I plot 0, 4, 1, 2, 3, 4. I plot negative 4, 0, 1, 2, 3, 4. and I draw the line. So this is f of x equals x plus 4. The next step is, if I'm asked to graph both on the same coordinate system, the next step must be to graph the line y equals x. And now, can anyone give us two ordered pairs that we can use to plot the inverse without any calculations? We want to graph the inverse, and we need two ordered pairs. And we don't need to calculate anything. Which ordered pairs will we use to graph the inverse? Anyone remembers? That's it.
4, comma 0, and then negative, I mean 0.
Yes,
4.
yes, exactly. We reflect this point here, 1, 2, 3, 4. And we reflect this point here at 0, negative 4, 1, 2, 3, 4. Exactly. That's the whole purpose. That's why we did this. Good. It happens that they are all parallel. I have to be very careful. So this is F inverse. Exactly. This gets reflected. That's why we graph y equals x. This gets reflected here, and this gets reflected here, as if this is a mirror, and we are just creating a mirror image. Good. Good. Next topic. Anyone would like to choose the next topic?
Can we do some exponential functions?
Absolutely. That's chapter 4. Good. Let's look at the review. Let's see what they have in the review. And the review starts on page, review exercises, page 538. Good. You want to look at equations, you want to look at word problems. Let's see where the equations are. Okay. We want to look at equations, we want to look at word problems. So here's a word problem, the function such and such. I didn't read the problem, I don't know what they want. These are equations.
We could do some equations.
Very good. Here they are.
$72.
Very good. 72. 72 is the most difficult one. Why? Because we do not want to approximate till the very last step if we need to. So when I'm facing or I'm asked to solve a exponential equation, I always hope for the same base or that I can present this base with this base or this base with this base. It's not possible. 3 and 7 have nothing in common. So therefore, my only chance here is to apply natural log. You can apply common log, but to both sides. You cannot apply natural log here and common log here, or vice versa. So when we apply natural log to both sides, or we can apply log to both sides. It doesn't matter. But now I have to be careful, because when I bring down the power, if you remember, this is the power rule. If I omit to put parentheses, the whole thing collapses on me. Again here, I have to put parentheses and then natural log 7. Now I have to distribute. I know this looks fancy. It's just a poor number. It looks fantastic, but it's just a number. I have to distribute this number here, and I have to distribute this number here. So this is x natural log 3 plus 4 natural log 3 equals 2x natural log 7 minus natural log 7. Now, the next step must be realizing that these two belong on one side, on the same side, and this has to be moved to the other, because the terms with the variable have to be on one side, left or right, it doesn't matter, and the terms without variable have to be on one side. But when I do that, I will not be able to combine these. They're not like terms. So I will have to factor out x. So natural log 3 minus 2 natural log 7, x times this, and x times negative, because I move it to the other side, it changes its sign. And then both of these are negative, natural log 3 minus natural log 7. Now I have the final answer. All this over all this. So negative 4 natural log 3 minus natural log 7. Do not try to simplify anything. This is carved in stone. We cannot simplify terms. Now, the question is this correct? I don't know. So what I'm going to do is, if you have time, you should always do that. Or make an asterisk and say, I'm going to come back when I finish my test and verify. So you don't waste your time and finish the test and then come back and verify. I put this in the graphing calculator, and then the number 3 to that number plus 4 should be very close. It's not going to be exact because I'm approximating. Should be very close to 7 raised to 2 times the number minus 1. If these two are equal or very, very close, then this is correct. So now the difficulty here is to put this correctly in the graphing calculator. Because if I get something silly here because I didn't put it correctly, and I check and I'll say, oh, no, it's wrong. So this is not very easy. You have to be very careful how you put in the graphing calculator. So let's do that. So remember parentheses. A lot of parentheses here. Parenthesis for the top, negative 4, natural log 3, close, minus natural log 7, close, and close again for the top. Now divide, close or open for the denominator, natural log 3, minus 2 natural log 7, close, and close for the bottom. And now hit enter. So I got 2.2699. What I'm going to do is this. 3 to the power in parentheses, the previous answer, plus 4. And I will move the right term to the left-hand side, minus 7 to the power in parentheses 2 times the previous answer, and minus 1. So let me explain why I did this. If I want to use the previous answer, it will only work for the first piece, not for the second piece. But if I put them together, then the answer when I hit enter should be 0. It may or may not be exactly 0, depending on the so-called tolerance of the calculator or the software. But the answer should be 0. If it's not 0, it should be a number extremely, extremely small. Since the number is 0, it means that -4 natural log 3 minus natural log 7 over natural log 3 minus 2 natural log 7 is indeed the correct answer. So instead in checking it in this form, I checked it in this form by simply moving this term to the other side. Why? Because I wanted to call the answer. I didn't want to punch in that silly number. What was it again? I didn't copy it. So x is approximately 2.26992. If you put that in truncated, you will never get exactly 0 because we're putting error in. But if I ask the calculator to use the entire answer, the whole thing, not just the truncated number, then I should always get what I'm expecting to get. Any questions? Okay, I'll stop and keep quiet for 10 minutes, not 20 minutes, sorry.